started to solve equations, and you had, like 6 steps for solving equations, right? So today what we're going to be doing is in 2.5, it's more of the same. The only difference is in 2.4 you were working with your variable only on one side of the equation. Today we're going to do it where your variable is on both sides. That's going to be the difference, okay? So just a little bit more complicated, but not too bad. So let's just kind of go over what the steps were for solving your equations. What's my 6 steps? Number 1 is what? Remember? Yeah, fractions. Okay, so if you have fractions, or yeah, if you had decimals, you could eliminate those. And you're gonna, multiply by your LCD. Okay? What's your second thing that you do? Yeah, distribute. So if you have parentheses, right, you're going to distribute. Okay, third. Combine like terms. Okay. Okay, your fourth step. The addition property of equality. I'm just writing shorthand here. The 5th step is the multiplication property of equality, okay? And your last step, check it, okay? That's the step that not everybody likes to do, but which is very important because in algebra we can always check everything, okay? So we're just going to jump right in here and go through a few examples and talk about some of the problems you might see. Okay, so there's our first one. So we don't have to do step 1. We don't even have to do step 2. We're going to skip right to step 3. What are we going to do on that step? Combine like terms. Let's start on the left. What have you got that's like? 4x negative 6x. So that's going to give me a negative 2x. I still have my 2. And then on the right, what can I combine? 28 and 4, right? This is an 8x, so that just kind of stays. And so 28 plus 4 is 32. Okay, so now I've got x's on both sides of the equation. That's okay. You just need to get them to one side or the other, okay? Now, some students like to always solve from the left so that their x is always on the left. Some students like to solve on the right. Me, myself, I like to just try to stay positive, okay? So just because you don't do it like I do it doesn't mean that it's wrong. It just means you have a different style. That's okay, just as long as you're getting the right answer, everything's good, right? So what would you do on this next step? I need to get the x's both on the same side. So add 2x. Now you could subtract 8x, but then you got a negative situation, and it's not bad, but it's just usually there's less steps in making it positive. So I'm going to take this 2x over to the right. So that leaves me a 2 here. I've got how many x's? 10 x's. And then I have plus 32 here. So now my next step is to just get that 32 over to the other side. So I'm going to do that by subtracting 32. And that will leave me 10x here. How many over here? Negative 30. And always be careful with your signs. And then I just have to divide by 10. So x is going to be negative 3. Okay? So not too bad. That one's not too bad of a problem, I don't think. All right. So now let's do one where we have to distribute. So I'm going to erase this. Okay. So this one's not too bad. Only one more step than the last one. So I need to distribute first because I have those parentheses, right? So when I distribute this 3 through, what am I going to get? 3x minus 21, right? 3 times 7, 21. Okay? Over here on the right, I'm not really going to need to combine anything, but I will have to combine on the left. So I'm going to have a negative 21 and a plus 2, so that gives me negative 19. Okay, now what would you do?
Plus 19 on both sides.
Yeah, I mean, I always do my x's first, but that's just me. Yeah, I mean, I subtract x, 3x from both sides. You can do your numbers first. I don't know, I'm just in the habit of always doing my x's. Now that's going to leave me with 1x or just x, right? You can write the 1 in there if you want. And then I just need to get rid of the 4, so I'm going to subtract that off from both sides. So my answer is going to be what? Negative 23. Negative 23. Okay? So, not too bad. Any questions on those? Okay, let's do it with a fraction. Or actually, let's do them with decimals first. And then we'll get into the fractions. Okay, so you guys give that one a go. Let's see if we all come up with the same answer.
Is that 122 or 1.22?
1.22. I'll make my dots bigger. How are we doing? Got an answer? Almost. You have an answer? Well, don't be shy. What's your answer? What? It's okay if it's wrong.
Negative 1.32.
Negative 1.32. I think that's close. Negative 1.93. That sounds good. Okay. Now, I kind of, as I was walking around, I saw a mixed bag. Some of you stayed with decimals, which is fine. Some of you eliminated decimals. Okay. If you eliminated decimals, let's just briefly talk it through. What would I get here? I'd be multiplying everything by 100. So I'd get 825x plus 650 equals 425x, right? Minus 122. Okay, so that's good. All right. So what did you do? We'll just stick with decimals. what did you do? Did you minus 825x or minus 4.25x? Minus 4.25x. From both sides. What does that give me over here on the left? 4x. Okay, plus 6.5. And then I've got my negative 1.22 sitting over here. So now I want to get rid of that, right? So I'm going to subtract it. Okay, so I've got a 4x. And over here, remember, watch your signs always, because I've got two negatives, so it's going to go more negative, right? So I've got 7.72 negative, and then divide by 4. So how many people did this by hand? Sweet. But did we get the right answer?
I got something.
Okay. You got something different?
Yeah, I got 1.0805.
Well, let's quickly divide out, right? Well, I know 4 goes into 7 once, right? I'm left with 3. So 4 into 37 goes 9 times is 36, right? So then I've got 1 left. I bring down my 2, so I got 4 going into 12, which is 3, and then it does have to be negative. Okay?
Oh, I did 7.2 instead of 7.72.
Yes, and that's very easy to do. Very easy to do. Okay? So if you didn't quite get it, hopefully you know where you messed up. That's the important thing, right? Okay. Any questions on that one? All right, let's do a couple of fraction ones then. Okay. All right, so this is where we're going to have to use all of our steps. Now, even though I teach clearing fractions, and I'm sure Stephanie does as well, a lot of students will still just try to find a common denominator and slodge through all the fractions, okay? You'll get through it. It's just slower, okay? And a lot more steps. So what we're going to be looking for here to clear our fractions, and clearing fractions is really nice because within one step you don't have fractions anymore, and that's really good news, right? So I always have to look for what my least common denominator is, my LCD. What is it in this case?
24.
Yeah, now you could go 24, it is a common denominator, right? And you'd still be okay, but the least one is 12, okay? So here's what I'm doing, is essentially I got to multiply. Now remember, whatever you do to the right, you got to do to the left. So I'm going to be multiplying both things by 12, right? Which means I have 2 terms here, and that's what where the problem lies, is a lot of times students forget to put that 12 through both terms, okay? So let's just kind of write it out, just so we are all good. I'll write out my distributing step, and if you have trouble, writing out this step is good, because then you can just kind of get through everything. I guess I'll write it out one more time here. Okay, so now that we've kind of written this step out, we can go through and simplify everything, okay? So 4 goes into 12, how many times? 3 times, so I'm left with
3x.
3x, right? Because I got to go 3 times my 1x. Okay? 3 goes into 12, how many times?
4.
4 times. Now here's where you got to be careful. I got to go 4 times 2x, so that's
8x.
8x. Okay? And then 6 goes into 12,
2.
2 times, so I'm just going to have 2 times 1 or 2. Okay? So within one step, I just have no fractions left, and that's why this is so nice. Okay, it does take a little practice if you're not really good at it, but you can get there. Now what would you do next? Subtract 8x. Now I'm just going against the rule I just told you that I have, right? Is that I try to keep everything positive. But if I minus 3x, you know, I'd have more steps if I was doing it the other way. So I don't always abide by my own rule. So that gives me negative 5x, right? Equals 2. And then I have to divide by negative 5. So my answer is going to be
Negative 2/5.
negative 2/5. Okay? Yeah. Well, what some students will do is they'll just turn everything into 12ths and keep it with fractions. And then in the very last step, what you have to do is just multiply by your LCD. Same thing. Is that what you tried to do?
Yeah.
Yeah. It'll still work. Did you get the same answer?
No, that's gonna
Oh. Okay. Well, you can come back and look at it in a minute if you want. Okay, other questions on that one? Okay, let's do one more quick one and then we'll go to break. So this one's going to have a fraction as well. Okay. So I only really have one fraction in here, right? But I can still get rid of it and make my life a lot simpler. What am I going to multiply everything by?
5.
5, right? So, I mean, this is going by 5. And then over here, I'm going to have to multiply this whole thing by 5, right? Okay? So, over on this side, on the left, okay? This isn't too bad. Now that I've distributed, my 5s will go to 1. So I'm going to be left with just x there, okay? Here I've got 5 times 5, so that's 25, okay? Now let's look up here. Do I need to distribute first and then multiply by 5? Can I just multiply and then distribute?
Yes. Yeah.
Sure. Because this is just multiplication, 3 terms. Here's a term, here's a term, here's a term, right?
Hello?
So I know a lot of you would probably distribute and then multiply by 5, but it's actually pretty slick if you just go, oh, okay, well, I got 5 times 3, so that's 15, and then I can distribute, okay? Either way will work. What you have to be careful about, though, is that sometimes students will multiply it twice, and then they get these really crazy numbers, and it's not all good, okay? So just make sure that you know how you're going to do that. Let's distribute it now. 15 times x is just 15x. 15 times 3 minus 45, okay? Then, what would you do now? Subtract the x. Okay, so I got 25 here. How many x's here? 14x. Now I got to get this 45 over to the other side, right? So I'm going to add that. So 25 add 45 is 70. And then I'm going to divide by 14. What's 70 divided by 14?
5.
5. Okay. So that's why clearing fractions is kind of nice. You could have found the common denominator of 5 of everything, but boy, it's going to be a lot more work, right? A lot more steps. So it's good if you can do it. If you have to do it the other way, just slog through it. Yeah, you could have, like if you found 5 as a common denominator, of course I would distribute that through and then 5 find 5. You'll still get there, just it'll take you a little longer. Okay? All right, let's take our break. And if you didn't finish your quiz, finish it.
So how long do you need that back?
Yes.
Yeah, you're doing it.
No.
Okay, so what you have to think about is this. So what you have here is you have
I was like, I thought I was just crazy.
times 3
They're not
times
looking at
x.
animals.
Okay, think of that as like a gradient. Okay, so you can multiply these up in any order because that cumulative property. So see what you did.
I just did everything.
So you multiplied by 5 here, but then you also multiplied the 5 by the 3. And you don't, that's not necessary. Okay? So if you would have done that, but then this is a 3, you would have been in business. Okay? Because essentially what you did is you did an extra number there. So kind of think of it as just 3 different, so you got 3 terms. This is all one term, okay? So the other thing you could do is you could have gone 3x minus 9 and then multiplied that by 9. And
I was always doing
this. Yeah. Yeah. Does that make more sense right now? Okay, so 3 now I would use 12 because 12 won't be able to be.
So you do have to find everything.
So what I would do is I would use 24.
Okay, I think this is the other one. So you 24 here, but then I
So
would
you did 24.
and then
Which is 9.
oh, nice. And then
And here you would have gotten 3 and then 6.
yeah, and you just did it. So then
Yeah, so then yeah, you have to control them and increase the value that you have to take.
Okay.
And so what you did really great, so your answer is going to be 15.
Okay.
Okay.
So I think I have to translate.
Yeah,
Do I?
so that would definitely work.
Okay, thank you.
Yeah, not the second way.
Okay, this way, okay.
The first way you did it.
Okay. That's not gonna work then. Okay. And then the LCD is 12.
Okay, yep.
Then solve the problem, I don't want to do this.
Okay, so on this side, I'm still writing my 12 here. And then you'll do 6 and 12, and go twice, right? But then you're going to have to distribute that. So it's going to look like this. Okay, I mean, you're just doing it, instead of this, you've got over this way. Okay, but this is going to be the same thing. So you'll go 8n minus.
Okay, so then I'll add. Yeah, that's fine. The 20th is a happy year for my So I thought next week
Yep.
would be that one, but it's
Does that make sense?
yeah, because you did here too.
And so on that one,
Yeah. Yeah, so then
now with your LCD, you're going to use, no, don't use 3 because, see, because you got a 6.
Did you have a quiz on it?
So see, you're trying to go
No, the
backwards.
quizzes are random.
You need a multiple of all
Yeah.
those.
So,
So it's not, it can't be 9 because 6 can't go into 9. So what's your next choice?
I wish she's not as you were in half.
Yeah.
It's just use 36
Yeah.
for 18.
18 will work.
If you can't make it up,
No, 16. So try it with 18 and then you can do it. Okay? And then again, you'll have to do both terms. So that would be 18. Yeah, but you can simplify, so now I'm taking 8 plus, so you have to put that. Does that make sense? And then on this side, remember you go through the 18 labels. Okay. Well, except for, so you're just simplifying, right? Well, actually, so on this one, okay, because you don't have an equal sign here, the only two you really have to turn into common denominators is the 6 sevenths x and the 7 x. This can just stay, because that's just by itself, right? I mean, I would distribute your negative through. That's going to change your signs, right? See, then you're going to have a situation where you have, let me write it right here. So you're going to have like negative 6 sevenths x, right? And then you're trying to combine that with plus 7x. And then you're plus 1/6 there. So see now, you just have to turn this into sevenths. Okay? So this is already negative 6 sevenths. How many sevenths is this actually? Well, so see it's 7/1 right now. You're turning in the sevenths, so it's going to be 49, right? Because you're multiplying by 4. So then you just have to go minus 6 plus 49, combine that up. And then this is just going to be coming out, right? No, you don't need to find a common, and it's only because this is simplifying, not equality. Yeah, and that does confuse a lot of people, because people will try to, when they're simplifying, they'll try to find a common denominator, and you don't need to. I mean, just with the like terms, okay? All right, does anybody else have a quiz? Did everybody sign the roll? Did you get them?
You got it?
got everybody back, it looks like. Alright, here's one of the last ones. Doesn't look too bad, right? What do you think? Doesn't look too great either.
Is that an S? It's 5.
It's a 5. I know, I've got like the worst handwriting ever. You don't know what some is, just ask me. Alright, so I've got two fractions here sitting in front. This is going to be similar to what we just did, right? We just have to be a little bit careful if we're clearing fractions. What's my common denominator going to be, or my LCD? 10, okay? So, I can put 10 over 1 there. I can put 10 over 1 here. Remember, that's going to be a bracket though, right? So I really need to multiply by 10 here as well. That's what a lot of students will forget, is when I distribute through, I got to do by 10 here, okay? So I'm going to kind of erase my brackets just so I don't have to rewrite anything over. Okay, but I'm just going to put a 10 here. Okay. Now again, this is just like that other one. Think of these as 3 terms, like an A, a B, and a C. It's perfectly fine for me to simplify here and then distribute, versus distributing, like who wants to distribute 3/5 x, distribute that fraction through? I don't, right? It's just a little bit easier to simplify those first 2 terms. So let's do that. 5 goes into 10, how many times? Twice. Okay, and then I've got 2 times 3, so that's 6. And now I can take my 6 and distribute it through. Okay? Same thing here. 2 goes into 10 5 times. I got 5 times 1, so 5. And then I've got x plus 1. Now let's not forget the 2. I still have to multiply 2 by 10, so that's going to be 20 plus 20. Okay. Is everybody good with that step? Does that make sense? Yeah.
It doesn't matter if you do the, what is it called, outside of the parentheses first, or inside, and then like, when you distribute. Like you said, you don't want to do 3/5 to distribute to a 5x plus 2. So it doesn't matter, you can multiply either way.
Yep. Yeah, because again, I can look at these as an A, B, and a C, right? This is just a term. It's like one number. So I can multiply, you know, normally if I multiply together, I can multiply A times B, then multiply C. I can multiply B times C and then multiply by A. I can multiply A times C and then multiply by B. I can do it any way I want. Whoa. So the best way is to get rid of the fractions though, right? Because none of us like to do fractions. I mean, if you tried to distribute the 3/5 through, you know, you could do that, but then you're going to have fractions longer, and then you still have a mess. So you want to, the goal is to get rid of those fractions, okay? So yeah, it's perfectly fine to multiply those first 2 numbers together first. Okay, let's distribute now. 6 times 5x, 30x. 6 times 12 is a 12.
6 times 2.
6 times 2 is a 12. My mind and the hand don't always work together. Okay, 5x here, 5 times x, 5 times 1, 5. Don't forget that. And then plus 20. So the only things I can combine is on the right. And that's going to go to 5x plus 25. Oh, you guys let me forget my x there. Don't do that. Okay, now what? Subtract 5x from both sides. Okay, so that's going to give me 25 x's. And I still have my 25 over here, so I want to get rid of my 12. I'm going to subtract that. So 25x equals How many?
13.
13. Divide by 25. And I get 13/25.
No.
Is it negative? No, it's positive. Because my 25 was positive, my 12 was negative. So it's going to be positive 13. Okay? All right. Are we as clear as mud on those? You want to do one on your own? Let's do one out of the book before we finish this up. Let's see. Somebody have a preference?
Easy.
Easy? Nah, it can't be easy.
Fine, it's super hard.
How about let's do 71. We want to get good at these, right? You thought you were going to get rid of fractions, didn't you?
And you were like, this is the last one.
You're never going to get rid of fractions. Can I just tell you that? Okay. There it is. Now, if you're still having trouble with that LCD stuff, let me know. I'll come help you. Yeah. I'll read it to you. 3/5 times x minus 6 equals 2/3 times 3x minus 5. How are we doing? Excellent. Okay. Okay, it's good that you're missing the negative, so let's see who you lost it. It's a positive. That's what it is. Okay. Yeah. Always just have one of those times. Okay, so you should be getting negative 4/21, right? How are we doing? Good? Okay, what'd you multiply everything by? 15? Okay. So 5 goes into 15 3 times, right? 3 times 3, 9. Okay, and then I can distribute that 9 through. 3 goes into 15 5 times. 5 times 2 is 10, and then I've got 3x minus 5. Now let's distribute everything through. I've got 9x minus 54, and then I've got 30x minus 50. Okay? Now what'd you do? Subtract the 9x?
Yes.
So 9x. Okay, that gives me a negative 54 here. How many x's? 21 x's. I'm going to add 50 to both sides. Now just watch your sign here. So I've got a negative 54 and a plus 50, so a negative 4. And again, you may not have done it exactly this way, but that's okay. And then you divide by 21, divide by 21, and you get your negative 4 21st. Okay, so just be careful of those signs. But hopefully those are a little bit better now. Okay? All right, now, in this section, you're going to find a lot of our answers. So everything we've done up to now has had an answer, right? We actually have a name for that. And we call it a conditional equation, okay? But we also have some other possibilities that you're going to run into. And so let's take a look at those. Let me write down this example here.
Is this still 2.5?
This is still 2.5. The tail end of it. Okay. So let's go through all our steps. What would you do first here?
That plus 6 minus 0.
Yes. You guys aren't used to me. Okay.
Combine, like.
Well, I'd probably start with distributing, right? Get that out of the way. So let's do that. I've got 4x minus 4 plus 10. Okay, I can combine up right here, right?
Yeah.
What's it going to be?
6.
4x plus 6. Okay? Over here, what can I do?
4x.
Yeah, a 7x and a minus 3x is a 4x plus 6. So, anybody see a problem here? Well, if I minus off 4x from both sides, what's going to happen? Yeah, those are both going to go to 0, right? So I'm going to have 6 equals 6.
It does.
Yeah, it's okay. You're going to see this, right? What's my answer to this?
1.
No.
0.
No.
Undefined.
Undefined? Well, close, sort of. It's all real numbers, okay? All real numbers. What does that mean? Well, that means I can insert any number into x and it's going to be a true statement, okay? I could put in 25, I could put in negative 0.2, and anything will work, okay? So,
How do you know when you solve it and when you don't?
okay, well, what's going to happen is, okay, so right here, when you get to this, 4x plus 6 equal to itself, okay, that should kind of give you a clue. If you don't see that, you try to minus it off. Well, what happens is people will go, well, that can't be right, and they'll try to fudge some sort of an answer so that they can get an exact answer. But this is a possibility, okay? So, you know, you can take it down to 6 minus 6. I mean, if I subtract off 6 from both sides, what am I going to get? 0 equals 0, right? So, if I've got something equal to itself, I know that it's going to be all real numbers.
So that's like the official sign for.
This is the official sign for all reals. Hopefully you learned that in 1.4.
So it's like an N with this squiggly line.
It's an R.
Oh. Oh, okay. With a line.
With a line through it.
So we can use that?
Yeah.
It's like to be official.
Yes, to be official. Well, isn't it kind of fun? You know, it's better than right now all real numbers, right? Anything that's quicker. Okay, I know that looks weird, but that's the thing. Don't try to go, oh, I have to have an x equals something, because this is a possibility too, okay? We call this an identity, okay? So it's true for everything. Okay, now we got one more possibility. So again, you've got the possibility of there's one answer. You've got the possibility that there's all real numbers. And guess what our last possibility is? All fake numbers. That's good. All imaginary numbers? No, good guess. Now you guys are going to make me paranoid. Okay. Well, what can I combine here on the left? 7x and negative 3x. That's going to give me a 4x plus 4. Okay? What can I combine up on the right? Negative 5x and plus 9. That gives me 4x plus or minus 10. Right? Anybody see a problem here? It's kind of the same thing, except for if I minus off 4x, right? I have 4 equal to negative 10. Does 4 equal negative 10? No. These are not equal to each other, so in this case we have no solution. Okay? Nothing we try to put in here is going to work. It can't. It's not going to ever have an answer. Okay? So no solution. We call that a contradiction. Okay?
There's no fancy sign for that one. Equals with the word in it.
Yeah, you can put equals. Yeah, no solution. Some people may put an empty set, but I don't know. I just write no solution. So the thing is on my math lab, I don't know if any of you have looked at your homework already, but you're going to be given these problems, and then you're going to have 3 choices. One will be x equals, and it will have a box, right? One will be all real numbers, one will be no solution. So you'll have to pick which one it is, okay? So just don't get freaked out on your math sometimes. I think a lot of times these when people will like, I need an x equals, right? So they'll try to fudge it in there when really it's a no solution or an all real number. So you just have to be a little bit careful on those, okay? Questions on those 2 kinds that you're going to run into? Okay, so let's jump into 2-6. We'll see how we do. Hopefully I can finish it. Okay, so 2-6. This is going to be formulas, okay? So, how come, why do we have formulas? Torture us?
They have a soft copy.
Yeah, I mean, because we have things that we know if we plug it in and do this, it's going to work, right? It's been proven before. So they're actually kind of nice, even though people don't really like them too much. Okay? The thing is you guys have a lot of formulas in your brain. Okay? You already know a bunch of them. One of the formulas that they use in this section is simple interest. What's my simple interest formula?
I equals RT.
Yeah, I equals PRT, right? The I, my interest, what does P stand for? Principal, right? R stands for rate. Now a lot of times you're going to get that as a percentage, and what do you have to know? You have to change it to a decimal to multiply. So it needs to be in decimal form to multiply. And then my T stands for time. And what do I need to know about time? That it's in years. Okay? So the thing is if you run into a situation where it says, okay, find the simple interest and it's for 6 months, what do I have to do then?
Divided by 2.
Put 6 over 12. Okay? So you'd have to always put it over. So if you're in a month situation, put it over 12, because there's 12 months in a year. Okay? Now I'm going to kind of flip around a little bit, but let's just look at your exercises. okay? I'm on page 140. So you'll see a problem like 15, okay? 15 says I equals PRT, simple interest formula. Find I when P equals 2,000, R equals 0.06. These guys were really nice. They already changed it to a decimal for you. And T equals 3, okay? So when I'm doing formulas, I always write my formula out and then I just start plugging stuff in. So P equaled what?
2,000.
2,000. R equaled 0.06. Was it 06?
Yes.
Yeah, 6%. And the time was
3 years.
3 years. And I don't need to do anything to that, right? Well, I shouldn't need a calculator for this, hopefully, right? What's my answer going to be?
6, hold on.
Well, I've got
No.
2,000 times 3, that's 6,000, okay? 6 times 6 is 36, so I just got to figure out where my decimal goes. Is it 60 or 600? It's going to be 360. 360. Okay? Is everybody good with that? You can punch it out if you want. Well, remember, I've got 2,000 times 3, that's 6,000, right? I got 6,000 times 0.06, but I know that 6 times 6 is 36. I just got to figure out where my decimals are all going, okay, right? Okay. Hopefully everybody trusts me. If you don't, punch it into your calculator. Okay. All right, so that's simple interest formula, okay? Another formula that you guys have is distance formula. And that goes distance equals RT. So it's distance equals rate times time, okay? Now, hopefully you guys have heard about this formula before. It's a fairly common one, okay? Let's just look at number 11. So number 11 just says distance equals R times T. Find D when R equals 60 and T equals 8. So my rate was 60. My time was 8. So my answer is
time in minutes or hours and what's the rate?
time. I don't think the time, I think it's just in hours. It's not minutes, for sure.
Just depends
Okay.
on what you're doing.
Yeah, I mean, you may, but believe me, these ones are pretty straightforward, okay? I don't think you'll have to get too complicated on these. Okay, so what's my answer here?
480.
480. Okay? All right. Now comes the fun part. We have a lot of formula, geometric ones that we gotta review, okay? So I'm gonna kind of make a chart here. And if you think I'm a bad writer, just wait till I start drawing. I'll try to make these big. Yeah, this is better than I normally do. You guys have me all paranoid. Okay, hopefully that looks like a parallelogram. I'll put a few over here too. We need a triangle. Okay, so we're going to do perimeter and area. Okay. So let's look at these real quick. So right here, hopefully you can tell this is a square, right? What do we know about squares? All sides are equal, so normally you're given an S, right? What is my perimeter on a square? What do I have to do? Well, you can add up all the sides, right? So if I told you that was 2 inches, I could go 2 inches plus 2 inches plus 2 inches plus 2 inches.
Square.
Or I could times 2 inches by 4, right? So my formula is just usually 4S. Okay? What about my area? What's my formula there? Well, yeah, normally with a rectangle we go length times width, right? Well, with a square they're all the same size, so it's just side squared. Okay, that's my area formula. Okay, here we have a rectangle. What do we know about them? Yeah, these two sides should be the same as those two sides, so we have a length and a width, right? So my perimeter is, well, you can always add up all the sides, right? Worst comes to worst.
2L plus 2W.
2L plus 2W. Okay, sometimes you'll see it like this, where I just fold my 2 out. Okay, it's the same thing. What about my area? Length times width, right? Okay, now here, I didn't draw my height yet. There's a parallelogram. Normally it has a height. What do you know about this, a parallelogram? Well, normally it's the same as a rectangle, right? I'll have 2 lengths that are the same, 2 widths that are the same. They're just kind of tilted there. So what's my perimeter? Just going to add up all the sides again, right? Sometimes you'll see it just written like A plus B plus C plus D type deal. Okay. Yeah.
So it's the same deal, 2L plus
Mhm.
2W.
What about your area of a
Length times width.
trapezoid, or I'm sorry, parallelogram? Is it length times width? Yeah, it's length times your height, right? You're always going to get your height coming off of your right angle. Okay? So it's similar, just slightly different, length times height. Okay, what about my triangle? Now again, you're going to have heights here. Okay? And with my triangle, well, I'm just going to add up all the sides. Okay, so that's just A plus B plus C for perimeter. What's my formula for a triangle? You remember that one? Yeah, base times height. And remember, your height and your base always come off of that right angle. Okay. What else? 1/2 times 1/2, right? Because a triangle is half of a parallelogram. Okay, that's where the half comes from. Okay, what about the trapezoid?
So it would be 1/2
base times
times
height. Yep.
So you would do
1/2
base times height first.
It doesn't matter because it's the same thing.
Okay.
I've got 1/2 times base times height, so you could multiply those two, then multiply the height, multiply, you know, however you want to multiply it up. Because it's all commutative, right? Okay, perimeter on a trapezoid, same deal. I'm just going to add up all the sides. You'll have 4 sides. Does anybody know what my formula for area is? It's similar to the triangle, right?
Half the height.
So I'm going to have, is it still a half?
No.
Yes.
That's a guess. I'm just guessing.
Well, this part stays the same, right? The 1/2 and the h. But remember, on the trapezoid, right, I've got a base here and kind of a base here. A lot of times you'll see a base sub 1 and base sub 2 type deal on a trapezoid. So like on a triangle, the base comes off that right angle, okay? On a trapezoid, the base comes off the right angle, but this is also a base as well, because it doesn't have a pointy top. So what I have to do,
That's the requirement? It's a 25.
just as a difference. Well, I mean, if it went up, right, it would be a triangle. So the way I like to think of this is base 1 plus base 2. In the book, they say A and D, I think. But you're just looking at both the bases, adding them together, okay? Circles. What's my formula for a circle? Well, my perimeter is the circumference, right? Pi d.
2 pi
2 pi r.
Oh, there we go. Very good. 2 pi r. Okay? And remember with circles, we know that the radius goes halfway, right? The diameter goes the full way. So sometimes you may be given a radius, sometimes you may be given a diameter. You have to adjust that to your formula. If I'm given a diameter, I'm going to have to chop it in half, right? Okay? And then my area of a circle, what's that formula?
Pi r squared.
Pi r squared. Okay? Now the only other thing to remember with all these different perimeters and areas is, if I'm doing a perimeter, what's my units? Is it normal or?
Yes.
Yes. When you have an area, your units are always squared. You gotta make sure you get those units on there. Okay? Okay, any questions on any of these shapes? Got a couple more. It gives you some volumes too. I know. All right. So let's see. Now this is where the drawing could get really sketchy because, yeah, that's close enough, right? What else do I gotta draw? I better look at it because I'm really bad at this. Okay. So we have a square or a cube. We have a cylinder. I guess that's. Remember when we have a cylinder, you're going to have a circle in there. And you're going to have a cone. Okay. And then we're going to have a sphere, which, ooh, well, that looks like an egg. You'll have to probably just imagine this. Pretend that's a perfectly round circle. Okay. Well, that's not too bad, I guess. All right, so we have a rectangular solid or a cube. What's my volume? Yeah, it's going to be base times height times width. Okay?
That's what
Hang on, base
area
times.
or
What am I doing?
I don't know.
Okay, or length, okay?
That's volume. Wait, what are we doing? What are we
This
doing?
is volume. These are all volume formulas, okay? Now, what's your units? Let me just put length so the only thing that's really changed is you're going to have a width in here, right? So it's like your square. But it could be a rectangle too, okay? It could be a square, it could be a rectangle. I happen to draw a square, okay? But all you're really adding in there is a width, okay? What's your units?
Will these be given on the test or we can
I don't think they'll be given on the test, okay? So that's the bad part. You gotta have all, now hopefully most of these are in your head, These ones may not be, the volume ones. Okay, the other ones should be, except for maybe a trapezoid. Okay? What about the cylinder? Now, the one thing you can remember about a cylinder is, right, I've got a circle here. Okay? What circle formula will I use to kind of get to here? Pi r squared, right? Because that's going to give me the bottom part here. And I can use that on both the cone and the cylinder here. Now, what's the other measurement I'm going to be given? Well, I'm going to be given a height, right? So for my cylinder, it's just height times pi r squared. So as long as you remember the area formula of the circle, you put in the height, you're good to go. Okay? Now what about the cone? That's a good guess. So the height is still going to be in there, right?
1/3.
But yeah, it's going to be 1/3. Okay? Not 1/2, but 1/3. Okay? So that's the only change from the cylinder to the cone. It's just the 1/3. So they're very similar. Now the sphere, it's kind of on its own. Now, does it have like an area type feel to it? Yeah, it's still got a pi r, but it's not a pi r squared, it's a pi r cubed. Okay? So this one is a tiny bit different. And then the fraction on the sphere is a little bit weird because it is 4/3. Okay? So 4/3 pi r cubed is that formula. But they're mostly similar, so if you kind of realize what you're working with, then you should be okay. Right? Alrighty. Questions on those formulas? So let's just maybe look at one problem. So let's see. Again, it's kind of just, I call these plug and chug problems, okay? So like if you look at number 34, okay, in your book,
On page 140?
yep, on page 140. Okay, you've got a big, huge, you've got a taller rectangle, right? I don't know, this isn't definitely going to be exact, okay? But they give me a 5 feet here, not to scale in big letters, right? 4 feet and 3 feet, okay?
I don't know if numbers are the opposite.
I know,
Oh, okay.
it's okay.
I didn't know.
I just drew my slants on the wrong side. It's okay, you guys can all just kind of turn. Okay, well, now you will probably have to know this formula. I would suggest when you're doing your homework, maybe make yourself a cheat sheet. And then once you get familiar with them, I think you'll pick them up if you don't already have them. Okay? The only thing I would do here is I would say, okay, I have a rectangular solid, okay? I'm trying to get my volume. What is my volume formula? It's length times width times height. Okay? I know all that. You know, you can put in 4 feet, 3 feet, 5 feet. And again, does it matter which way I multiply these up?
No.
No? What are we going to get?
60.
60. And then feet cubed. Okay? Don't forget the cubes part. That's important.
Everything is volume
Yeah. Everything with volume is going to be cubed. Okay. Now comes the fun part. I got about 8 minutes. We have all these formulas, right? So let's just use like perimeter. So I know perimeter is 2L plus 2W for a rectangle, right? So let's say I'm doing a problem and I actually have the perimeter, but I don't have the length, okay? We can actually manipulate these formulas so that we can solve for L, okay? So they'll maybe give you something like this, and then they'll say solve for the length, okay? Now we don't actually know numbers, we're just going to try and get an L equals situation going on here, okay? How on earth can I get an L equals situation going on here? Well, I need to isolate it, right? Now this is what freaks students out, is because I've got 3 variables in there, but my steps are going to be just the same as what I've been doing, okay? I want to get L by himself, so I got to get rid of this. How am I going to get rid of that? Subtract it, right? So if I subtract 2W, I'm going to subtract 2W here. Okay, that leaves me with 2L over here. What do I have over here? Well, I have P minus 2W. I can't really combine that up at all, right? Now what? Divide by 2. Okay? So then L is going to equal this whole mess right there. And it looks really weird, but that's good. So see, that way, if I was doing some problems and I had a bunch of lengths, but I wanted to know the length, but I didn't know it, I can figure it out. Okay? I know everybody will be like, that's crazy. But we do it all the time. We just don't really realize it. All right, let's look at let's look at 64 in your book.
Wait, I still have a question. So L equals P minus W, is that going to...
P minus 2W over 2.
But so you only take the 2's away on the other side.
Yeah.
I'm sorry, I just didn't quite catch it. Okay.
It's okay. I just didn't write it down here again. Okay, so I divided by 2 to get L by itself. So the answer is going to be that whole mess. Okay, here they want you to solve 4D. Ooh, right? Okay, well don't cry or get upset. It's not as bad as it looks, right?
So that comma 40 is like they're just saying solve for D?
Yep. So we want to get a D equals, okay? D equals, that's our goal. Well, first of all, I want to get rid of this, right? So if I multiply both sides by 3, I'm going to get rid of it, right? So 3 over 1, 3. You can put the 1 if you want, but it's going to be 3A, right? These 3's are going to simplify out, and I'm going to be left with M plus 2D. Now what? Subtract M from both sides. So I still have 2D here. Over here, what do I have? I have 3A minus M. Okay, now what? Divide by 2. So see how I'm following all those steps we learned in 2.4 and 2.5? Same thing. Okay, don't get excited that there's a bunch of letters and it's confusing. Just do the steps and you'll be okay. All right, so this is my answer right here. Okay? All right, let's do one more and then you guys will be done. Okay, let's look at 54. This one says PV equals KT. And I'm just solving for T. Yeah, easy, right? Okay, so I'm going to tell Stephanie that you guys were great. No worries on this part, right?
Uh-huh.
Are you gonna change it?
Okay? So, yeah, practice those up. You guys may have some questions because, of course, there's going to be some word type problems in this section, okay? The biggest thing is just one little tip. You're just going to have to be able to discern if something's a perimeter or an area, right? So if they're ever asking for fencing and stuff like that, what am I looking for? A perimeter, okay? If I want to know how much carpet I'm laying, I'm looking for an area. So that's the only trick, is deciphering which is which. Okay, just make sure I have all of your quizzes if you didn't get them turned in.
Okay, so the homework is just the stuff on the internet that we have to keep doing.
Yeah, I imagine. So the 2, 4, and 2, 5, or I'm sorry, 2, 5, and 2, 6.
Okay.